right, good morning, Algebra 2. As you can see here in the bottom right-hand corner of your screen down here, it's 6:26 in the morning. I got up super early to get here, and you can see my picture. I took this, and that's what I look like today. They say when you make video for your students, you're supposed to provide a picture to remind them, oh yeah, he's here teaching us. So here's what we're doing today. We are doing combination of functions. And to start this, we are going to introduce something called a function machine. So a function machine is just a graphic way to think about what a function is. So I have this rule here. Let's make this a linear one. Let's call this f of x equals x plus 2. And so with a function machine, we think of it this way. If the number goes in, it abides by the rule, and we want to find f of 2. So the output, we're adding 2 to the input, so I get 4. If I take this machine and I plug in 6, let's see, x plus 2 is 8. So I can have different types of machines. I can change my rule. Let's change it to a quadratic machine. So I can write f of x equals x squared. So let's put a number in. So if I put in 6 into the input, it squares it and it becomes 36. So we have this machine to think about the meaning of a function and what we learned yesterday. A function is a relationship between an input and an output such that every single input has a unique y. I can never have 6 coming in and then 2 numbers coming out. With this particular quadratic machine, if I put a 6 into the top, the only number that would ever come out is a 36. Let's put in a 10. If a 10 goes into the input, the only number that will ever come out is 100. So there's never a machine or a function machine where if I drop in more than one number, if I drop in a single number, I never get more than one number out. However, think about this way. Let's look at the quadratic machine. If I have f of x with x squared again, and if I know this, if I know that 4 comes out, is it possible to have more than one input? Yes. I can put in -2, or I could put in 2. So both of those input values have the same output, and that's okay. That's still a function. All right, so with these function machines, let's think about putting 2 of them together. So what it looks like is this. So if I have these 2 function machines, and let's say that this is a function machine that will double the input. So let's say it's 2x, and let's say that this is a function machine, we call it g of x, that square roots the input. So something like that. So let's put a number into both of them. Let's put the same number into both of them. So let's put in a 4 and a 4. So 4 goes into f, and I get double that, which is 8. And then 4 goes into g, the square root of that is 2. So what we want to do here is we want to think about adding these 2 machines together. So it looks like this, f of x plus, let me write it this way, f plus g of x, and I could write it as this as well. It could be f of x plus g of x. So adding these 2 machines together is one way to make a new function. So now I could do this. I can go f plus g, oh come on, smartboard, f plus g of, let's see, let's put in 4, which is nothing more than f of 4 plus g of 4. And I've already got those outputs. Let's see, if I put 4 into f, I double that and get 8. And if I get 4 into g, I square root it and get 2, and that gives me 10. So once again, we see one number going in, 4 going into the addition rule, and 1 number coming out. So that would be a function. Let's do that again, but this time we're going to do a different machine. And this time we're going to use a different operator. So let's do this. Let's call this machine f of x, and let's do this. Let's square root that. So we'll have the square root of x. And let's call this other machine g of x. And let's keep it simple again. Let's just take it x plus 3. All right, so let's choose a number to put in both machines. I'm going to choose let's make it easy here. I'm going to choose 9, and I'm going to put that in both machines. And if 9 goes into into f, I get the square root of 9, which is 3. If 9 goes in g, I'm going to add 3, which is 12. So, and this time, though, let's subtract the two machines. So I could do this. I could write f minus g of x, which is the same thing as f of x minus g of x. And then with numerical values, it looks like this. If I want to find a specific point, if I want f minus g of 9, that would be f of 9 minus g of 9. Well, we can see from the machines that f of 9 is 3, and then g of 9 is 12. So my single output is negative 9. So once again, I see 9 coming into the function, and then the negative 9 coming out. All right? So another thing to do with these machines, well, let's go ahead and introduce all of the operations. Here they are. We looked at the example where we can add them and then subtract them, but we could also multiply the two outputs together, and we could also divide them. So we can take our 4 arithmetic operations and make a different machine from two functions. So pause the video, take as much time as you need to write this down. Let's make sure we're still there. Are you guys still there? Check my recording. Yes, we're 6 minutes in. So at this point, I need to remind you, I need to show you a picture. There I am. Do you see me? All right, so I'm looking at you right now, but you don't see me except for that. Let's go back to you took some notes. So here is another thing we can do. We can actually add the expressions together. So first, we know how to do 1 and 2. Let's call that 1 and 2. Let's look at that. So f times g of 4 is the same thing as f of 4 times g of 4. So we find each output, and so f of 4 is found by using 2x plus 3. So that's going to be 2 times 4 plus 3. I'm going to multiply that by g of 4, which is, I'm going to square the 4. I'm going to take 3 times 4, and then add the 2. So arithmetic would tell us to do this. We're going to take, let's see, that's 8 plus 3 is 11. So that's 8. And then let's simplify this. This will be 16 minus 12 and plus 2. And we're out of room here. So that's going to be 11 times, I see 11 times 6, which is 66. All right, let's do the other example below that one. So example 2, f of 6 divided by g of 0. Now, I could have written that as, well, so I could write that as f of 6 divided by g of 0. And then we're going to evaluate each function at those numbers. So f of 6, there's f. I take 2 times the input plus 3. And then g of 0 is taking 0 squared. I'm doing 0 squared minus 3 times 0. And it looks like we're going to add 2. So just do the math here. This is going to be 15 divided by 2. So 15 halves. So another thing we can do, let's look at the left side of the screen. Let's call this number 3 and number 4. I can evaluate these machines without numbers, meaning give a general expression for the machine. So when I see something like this, I'm thinking this is the same thing as f of x plus g of x. And with that, I can think of each of these y values as a rule in terms of x. So now that becomes 2x plus 3 for the f. All right, and then let's use some colors here. And then I'm going to add g, which is x squared minus 3x plus 2. With this polynomial, I can combine my terms. So my answer would be this. I see 1x squared. I see a minus x and a plus 5. So now I have a general rule for the addition of that machine. Let's do the next one, f minus g. So I'm thinking of the rule for f, which is, again, 2x plus 3. And I'm going to subtract away the rule for g. So if I look for that, That's going to be x squared minus 3x plus 2. Now we need to distribute the negative sign and combine like terms. I see a negative x squared plus 5x plus 1. And identifying those like terms, I had 5x's, and then 3 minus 2 is the 1. All right. So here's a good example in terms of looking at this idea with a table of values. So here it is, two functions. Now before we actually had a rule that showed us, or one we could use to figure out the output. Now they just give us the output. So this is actually easier. So if I do this example, f of 2 plus g of 2 is what we want. Well, f of 2 is found right here. F of 2 is the y value when x is 2, that's 3. And g of 2 is the y value when x is 2. So that's negative 1, so the output is 2. 3 minus 1 is 2. Let's do that again. Let's see, g of negative 2 minus f of negative 2. So I have to evaluate negative 2 for each function. So g of negative 2 is right here. That's going to be 3. And then f of negative 2 is right here. When negative 2 goes into x to f, the y value is 3, and so I get 0. All right, the last example here, f of 1 divided by g of 1. Let's see, f of 1 is right here. So that's equal to 1. Sorry, that's equal to 2. And then g of 1 is right here. So that's 0. So this is, we've seen this before, this is undefined. So we would say this output is undefined. All right, you guys still with me? How far are we in? We are 12 minutes in, so let's go back and check. Oh, there I am. Hello. I'm here. We're trying to learn how to do basic operations of function machines. We have one more thing to do. We have composition. So let's think about our function machines again. Our function machines, if I have two function machines like this, the way composition works is actually pretty cool. It's real easy to think about with these machines. What we do is we go into the factory, and instead of having the machines laid out horizontally, I'm going to put one right here. All right. So what happens here is this. Let's call this. So this is called composition. This is a fifth way to think about how we could combine functions. Composition. So let's call this top machine. Let's call this f of x equals x minus 3. And let's call the bottom machine g of x is equal to 2x. So how this works is we take one input and we plug it into the top machine. So let's plug in 2. F says to take that 2 and subtract 3, and it becomes negative 1. Now the difference with this is now the output becomes the input for the second function. So if negative 1 goes into g, I get negative 2. Okay, so let's do that again. Let's do a different numerical value. Let's plug in 5 up here. 5 goes into f, and then we're going to get 5 minus 3 is 2. And then that 2 goes into g, and I get 2 times 2 is 4. So it's just the output of the first function becomes the input for the second function. The notation for this setup here would look like the following. I would want to do g composed with f of x. And another way to think about that, another way to write that is g of f of x. So that's the same thing. It's two different ways to write the same thing. So for this particular example, I would write g of f. Well, the input is 5. So 5 goes into f. Well, then the output when 5 goes into f is 2, and then g of 2 is 4. All right. All right, so one thing we have to think about composition is that the order does matter. So let's do this. Suppose that we go into the factory, the function factory warehouse, and we actually switch these around. So now f of x is on the bottom. So let's plug the same number in. Let's plug let's plug 5 into this machine. So if 5 goes into the top, notice now the G is the first rule we use, so the output would be 10. And then the 10 goes into the F rule, and then we get 7. So notice by switching the order of the functions, we get a different value. So let's compare that notation to the one we had. So the notation for this setup would be the following. We would go F composed with G of X, which is the same thing as F of G of X. So for this particular example, what we were looking at then is F of G of 5. And then here's one thing to think about. We read left to right. We compose functions right to left. So what I mean is this. If I see an expression like that, I first plug G into 5. Add this backwards. I plug 5 into G. The output becomes 10. We saw that right here. Then the 10 goes into F, and the output becomes 7. So there are your two different ways we can compose functions. Here's the actual notes if you haven't written anything down yet. So here is, we're putting one function inside the other. Here's the notation that we would use. And with the function machines, I showed you that we could compose the other way. We could have G composed of F, which is the same thing as G of F of X. All right, let's do another example, actually using functions. So here we have a situation where we could actually write the rule for a composition. So if I want F composed with G of X, I now am going to replace G of X with this rule. So this is F of X squared minus 3X plus 2. So if I put that expression into F, well, F says to take the input times 2 plus 3. So I'm going to take 2 times the input plus 3, where the input is nothing more than this sucker, X squared minus 3X plus 2. So on the inside, I see G. On the outside, I see F. So what we want to do is we want to combine like terms after we distribute. So we could do this and write 2x squared minus 6x plus 4 plus, and we'll get plus 3, and then combine that to 7. So 2x squared minus 6x plus 7. Now look how that will be different than the other way. If I go G, then this way. If I go G of F of X, this now looks like the following. Let's see if I can't use some colors here to help us out. So let's use green for F of X, and we'll use red for G. So let's see. This is going to be the same as G of, and then replacing F with the rule, I get the rule is 2x plus 3. So now 2x plus 3 is going to go into the G rule, which looks like this now. So I'm going to square something minus 3 times that something plus 2. That's what G does. G takes a number and squares it, and minuses 3 times it, and then adds 2. So now that something is not a number, it's a rule. So 2x plus 3, and then 2x plus 3. All right, let's look at the next example. Now, on your homework, you're going to want to have to FOIL this out, combine like terms. So let's see what that looks like. I'll write that down here. So let's see. That's, if I take 2x plus 3 squared, that's 2x plus 3 times itself. And then minus 6x plus 9, minus 9 and plus 2. Foiling, 4x squared plus 12x plus 9 minus 6x minus 9 plus 2. Combining my terms, I can see the 9's go away. I have a 4x squared, I have a 6x, and a plus 2. So we want to go ahead and do our simplifying when we have these polynomials. The next example. Now we actually find numbers. So f of g of 2. Let's see, that's going to be f of, well, when g goes into 2, g takes, it's right over here. Well, I'll put it right here, x plus 2. G says take the input and add 2 to that number. So that becomes 2 plus 2 is 4. And then 4 goes into F, which says take that number and put it underneath 1. So the answer is 1/4. The other one they want is G of F of -4. So once again, we read left to right, we compose right to left. So starting with F, I'm going to plug -4 into it and get G of -1/4. And then -1/4 goes into G, and G says to add 2 to the number. So 2 plus -1/4 is 7/4. And we are done. Woo! Let's check our time. The time here, we've only been together for 20 minutes. All right, so that gives you a lot of time to take that, the first item on D2L or Brightspace is practice on this, and then you got to take a quiz today. All right, so we'll see you guys tomorrow.